Okay, so yesterday we have seen the multi-delete, sorry, not multi-delete. We have seen a multi-load script, okay, how it is written and how to understand the multi-load script. Okay, what are the different declaration sections we have? What is the final multi-load action statement? You have explained the script, right? So we have seen the auto-generated script and we understood each section of the script. All the declaration sections, DML declaration, file declaration, table declaration, variable declaration, and then finally this is the action statement in the multi-load, that is import in file using fast load format, using the layout which is declared for the file, and apply the insert DML. That is the DML, whatever is assigned with the name insert DML. Okay, so it takes the bunch of records which are accommodated in the 64 kilobytes of memory and it applies the statement insert. Okay, so block wise, each and every block of statements, every group of statements which are accommodated in a single block are inserted into the table. So when we execute this and when we observe the log, you see, so it log on, process this is statements, and it started execution of the multi-load in different phases. Okay, if you note yesterday, there are several phases through which multi-load executes and it does its import operations. Okay, what are these phases? The first one is initial phase. Okay. The second phase is called DML transaction phase. Third phase is the acquisition phase, which is similar to the fast load's acquisition phase. Okay, how many phases we have in fast load? Anyone can remember what are the phases we have in fast load? Right. Right. We have two phases in fast load. Let me mute. There will be two phases in fast load. That is acquisition phase and application phase. Okay, so here the acquisition phase, the third phase of multi-load, is similar to the fast load's acquisition phase, but not exactly the same. It is similar. We'll see the differences. Okay, so the third phase in multi-load is acquisition phase. Okay, once it acquires the data, it starts the application phase. Okay, the fourth phase of multi-load, and then cleanup. Okay, these are 5 phases of multi-load to execute. Okay, so let us see what each phase does. Okay, so these are 5 phases: preliminary, DML transaction, acquisition, application, and finally the cleanup. So these are the 5 phases through which multi-load completes its load operation or import operations. Okay. Multi-load import task operations are always primary index operations. However, not allowed to change the value of the table's primary index. Okay, so please note, all the operations should be based on primary index. If there is no primary index involvement, maybe directly or not indirectly, it cannot do the operation. Okay. And through multi-load, you cannot change the primary index value. If there is any update statement for you which updates the primary index itself, you cannot use the multi-load. Okay. When we are doing insert, are we using the primary index indirectly? Okay, when we do the insert, it has to hash and it has to insert based on the hash values of the primary index. So we are indirectly using the primary index. So each and every operation what we do through multi-load should be based on primary index. Okay. And it permits non-exclusive access to target tables from other users except during the application phase. Okay, that means okay, non-exclusive access to target tables is possible. That means all other locks are possible on the target table during all the phases except the application phase. Because in the application phase, where it finally loads the target table, except this phase, in all other phases we can access the target table with a non-exclusive access. That means you should not give an exclusive lock, but you can apply access, read and write locks on the target table in rest of all the phases of multiload. Okay, but in application phase it won't allow you, because in application phase the target table would be having a write lock on it, but in rest of all phases the work table is accessed. So during those phases we can still access the target table with non-exclusive access, and it allows restart and checkpoint during each operational phase. In each phase it has its own checkpoint mechanism and it has its own check and restartability mechanisms, and we'll see in detail each phase. In preliminary phase, these are the tasks which it does in the first phase, the preliminary phase. It validates all the statements. Which statements? The multiload commands and the SQL commands. It validates for the syntaxes. Okay, and it starts all the sessions. Okay, two sessions are default. One is for restartability, another is for parsing the SQLs, and the rest of amps to do the actual loading operations or import operations. And it creates the work tables, the intermediate table which will load even before the target table. It creates all the error tables, two per each target table. One is the ET table, other is the UV table, and creates the restart log table. Okay, the first statement in the script, the log table. Okay, even before log on we have to declare a log table, so that log table is also created in the preliminary phase. Okay, and it apply locks to the target table. Which lock? It is not a write lock. Okay, it is access lock on the target table, and actually it does all the operations on the work table until the application phase, the fourth phase. Okay, so it does all these subtasks in the preliminary phase. It validates the statements for SQL syntaxes, semantics, and starts the sessions required to load, creates all the temporary tables, intermediate table required, then it apply locks to the target tables. And then the next phase, the DML phase, send prototype DMLs to the Teradata database. It stores DML steps in the work table. So whatever steps it has to execute to import through multiload, all these executable statements are written in the work table's headers first of all. Okay, and it adds using modifier to the request. That means if there is any variable to be parsed or substituted at the time of variables, okay, all the parsings, substitutions, everything would be done in DML phase. And it adds match tags to the request. It allows links between DML transaction and the record. Okay, what record to be inserted, what record to be updated, what record to be deleted, what record to be upserted, all the tags for each record based on the DMLs what you define in the DML definition. Each record is tagged with the DML on which it has to be applied. All these tasks would be performed in the DML phase. And then the third phase is acquisition phase, where it would start acquiring the data from the host file to the work tables. It gets the data from host and apply it to the appropriate AMP work tables. So it duplicates input records for each successful apply. Okay, there could be more applies also. Okay, in the script what we have seen yesterday, there are only one DML statement and one apply, but it could have multiple applies also. Based on the conditions, we may apply any of the DML on the record. Okay, so it would do a match, okay, which apply statement to be applied to which tag. Okay, all that matchings and the path to execute that particular statement on the record, everything is decided in the acquisition phase. Okay, once the data is acquired, the deblocking system of each AMP resends the record to the correct AMP based on their hash values. Yeah, this is the same we have seen in the fast load also, right? So when the loader slot gets the data into the AMPs, the AMP work tables, the deblocker system would start hashing those records and resend the records to the correct AMP based on the hash values. That's what happens here also. Okay, but here, along with that hash, it does the sorting of the reblocked records in the work tables. It sort by hash value and sequence to be applied. Okay, so in this acquisition phase of multi-load, it sorts the data based on the hash value, but it is not on the target table, but it is in the work tables. Okay, in fast load acquisition phase, we just acquire the data, but we don't sort it. After encountering the end loading statement, we'll start sorting of the data based on the row hash values. But in multi-load acquisition phase, it acquires the data into the AMP work table and it sorts the data also as per the hash value in the work tables. Yeah. And then it will start preparation for the next phase, that is application phase. What are the preparations? It upgrades the logs on the target tables to write, because till now it is an access log. In the acquisition phase, after acquiring and after sorting of the data, it would start upgrading the logs on the target tables to write, so that the next phase, the application phase, which writes the data on the target table, starts. It set table headers for application phases. This is effective the point of no return. It means once it starts loading the target table, it is point of no return, but it has its own restartability capabilities. The restartability mechanism and checkpoint mechanism also would vary in phase to phase. The acquisition phase, if the multi-load fails in acquisition phase, the restartability is different, the checkpoints maintained within it is different, and once the application phase starts, it is a point of no return, so it will maintain a different kind of restartable mechanisms. Errors that occur in this phase, that is acquisition phase, are loaded into ET table. So all constraint based errors are found here in the ET table. Okay, and those are loaded in the first error table called ET table. If it is a multi-delete, there is no need of the acquisition phase. And if it's a delete task we are doing through multi-load, we are not going to acquire anything from the host files, so there is no acquisition phase exists for a delete task of multi-load. And then finally, the fourth phase is apply phase, where it executes multi-load for each target table as a single multi-statement request. So it actually starts loading the target tables. Okay. End of host interaction until end of phase. Okay. So it won't do the host interaction now, because all the data is existing in the work tables. It will start reading the work table and loading the target table. AMPs independently apply changes to target tables. So every AMP would work independently based on the tags they have, which apply to be executed on which record. All the tags are already defined, so each AMP would individually work to load the table as per the apply conditions. So executed as a single transaction without rollbacks, restartable based on last checkpoint onwards. If something happened and in application phase, if failure happened, and when you restart, it restarts from the last checkpoint onwards, and it won't use any transient journals. And errors that would occur during this application phase while loading the target table, those are loaded into UV table, that is unique violation errors. All unique violation errors are found here in the application phase, and they will be inserted into the UV table. And finally, the fifth phase, the cleanup phase. Once the target table is loaded and error tables are loaded with corresponding errors, all locks are released, table headers are restored across all amps, the dictionary catches, target tables is spoiled, statistics are reported. Here the statistics means how many records read, how many records are inserted, deleted, updated. All those statistics are reported. And then the error code is reported finally, the sysrc. The target tables are made available to the users because it released all the logs. Okay, work tables, error tables, log tables, everything is dropped when it is success. A log table is also dropped when error code is 0. 0 means success. If it is 0, that means success. All work tables, error tables, log tables, everything is dropped and log off from all the sessions of apps. So it is quite opposite for the first phase, the preliminary phase. In preliminary phases, it acquires the logs, it creates the tables. Okay, it starts doing the process. In the cleanup phase, it will do all vice versa tasks. So it releases the logs, it drops the tables, it reports the statistics and cleans the whole process so that the tables are available for the users. So these are 5 different phases through which Multiload completes its import tasks. Okay, the only difference in multi-delete and multi-import are the acquisition phase won't exist in the multi-delete, but acquisition phase is necessary in multiload import task. And these are the logs acquired in the acquisition phase and application phase. If multiload failed during the first 3 phases, the lock is called as acquisition lock, and during this lock all DMLs would allow on the target table. When I say DMLs, data manipulation language, right? Inserts, updates, all those manipulation language comments are allowed, but all DDLs are not allowed except drop. You may drop it. You have a right to drop during the acquisition lock, but you cannot do alters. Similarly, when application phase starts, the locks are upgraded to write. So what we can do only the access on the DML. You can perform DML with an access lock. When I say access lock, it is only the read, that is dirty read. Again, in terms of DDLs, no DDLs are applied but except the drop. Okay, even in the acquisition phase, if something happens, it failed, and if you want to start from the first record onwards, then you may drop the target tables and you may recreate the target table from the existing definition so that you can restart by dropping all the error tables, work tables and log tables. The work table, error table, log table you drop manually, and you can drop the target table, you start the multiload. It starts from first record onwards. Okay, when everything is fine, when you want to restart from the last checkpoint, you won't do anything. You just fix the problem. If it is a server shutdown or something, you fix that problem and restart it. By seeing the log table, it will start from the last checkpoint onwards. Yeah, but in some cases, the restartability is not possible for some times, okay, wherever the data records are very much corrupted, and otherwise, if you want to load today's data file, but unexpectedly your script has picked up the sdisk file. So what you do? You have to load the new file from the first record onwards, right? So there we don't have a restartability because it is a logical error. It has picked up the last day's file instead of today's file. So what you do? Okay, the table is locked. You cannot do anything. Then what we'll do? We'll drop the table, the target table, and you may drop all the work tables, error tables, log tables, and then start the script again by giving the proper file path again. It will start from the first record onwards. So this is the restartability from the first record onwards. Okay, if it is a logical error, the server down, then if you restart it, once the server is up, it will see the log table and it will start from the last checkpoint onwards. And this is a sample of a multi-delete. Okay, how we can write a delete. Okay, any questions up to here? Anyone? Okay, so yeah, this is an example of multi-delete. So how to write the script? It is very simple. It is not import, so it is not much complicated. See, the first statement is always log table, and then the next statement is log on, and we are trying to delete the data from the tables. It is not import task, so begin delete. So this is the keyword you have to write after the begin statement. Begin delete mload. If it is an import, begin import mload. Right? So here our objective is to delete the data from a use table. So we are doing it like this. Begin delete mload tables employee. Then layout. If you want to pass any variables while deleting the data. Okay, if you don't have any variable, if it is a hard coded value here, the date, then you can simply write the DML statement. But if you have any variable to be passed, okay, what date data you have to delete from the table, you can pass it from the file. Okay, how to pass the variable values to a file, to external file. So if it is a file, we have to define the layout like this. So layout remove, the field is interim data, interim date star integer. So it is only one field we have in the parameter file. We declared that there is only one field to be read into this variable in underscore term date, and we use this in underscore term date in our delete SQL with a prefix of colon. So it deletes all the data where term date is greater than in underscore term date. Okay, so up to here what we did, all the declarations. The action statement is here. Import infile2 the path, and then apply the layout remove while reading this file, and it will automatically delete this because it is the delete. There is no apply required here, because if it is an import, then you may do different DMLs on different tables. But if it is a delete, it is a single table and a single task, so no apply command is required here. It directly applies the delete statement which you have written here. Okay, so it is simpler relatively when compared to the import statement because it works on only a single table. Okay. So delete task operates very similar to the import task with some differences. What are those differences? Deleting based on an equality condition with UPI is not permitted. If you have a UPI, there is unique primary index, and if you are using a equality condition on UPI while deleting the data, it is not permitted. Can you guess why? Yeah, sure.
Yes, so multi-delete, how is different than the regular delete you do in the SQL then? Why you need to use multi-delete if it's just deleting data from one table?
Yeah.
Why you have to do this whole scripting?
Yeah. So if you do a huge delete in SQL Assistant, would it maintain a transient journal? And
Yes.
Ashok, it is very, very high noise coming from. Can you do something so that you don't have much noise in the line?
I have noise?
Yeah, now it's fine. But sometimes
Okay.
when I'm unmuting you, I'm getting much noise, it seems.
Really? Okay.
Okay, fine. So when we do delete through a BTQ or through a SQL Assistant, how it operates? It is a transaction. So for each and every
Yes.
transaction, Teradata has to do transient journal. Right? So let's suppose if I'm deleting 100 millions of data from a target table, and if I use my SQL Assistant, To delete those 100 millions of record, it has to maintain the transient journal. So what is the transient journal? The before image of all the impacted records. So 100 millions records are impacted with this delete transaction. So it has to make a before image in this pool space in order to save the transaction.
Okay.
So during the transaction, if something happened, then it has to use this transient journal to get the status back of the table how it was before we started the delete operation. Okay, so basically it has to
Okay.
maintain the transient journal. But in multi-load, okay, when we see the major property of multi-load is it won't maintain the transient journal.
Okay.
Even in the import statement or even in the delete statement, it won't maintain the transient journal. But what it maintains to protect the transaction is the restartable logs, LOGs,
Okay.
logs.
So
So
in practical experience, right, you don't delete million records a day, right?
maybe
Sometime.
see sometimes okay, if you have a partition table, because in practical
Mm-hmm.
scenarios, what we do when we partition the data and when we maintain 24 months of data in that, every month
Mm-hmm.
we have to delete the last month data, right? The previous 24 months data we have to delete for every month. So it is a circular insert. So we have to
Okay.
remove the oldest data and we have to insert the newest data. So each month okay, there could be some millions of data we may insert. Okay, if it is a monthly job and it is inserted into the partition table, for every month the transaction table can be of millions of data. So how to delete this every month? So first we'll write a multi-delete there where you will delete
Mm-hmm.
a last partition and then you will write an multi-load import to load the new data into the partition table.
Okay.
So if you use the BTQ to delete those millions of data,
Mm-hmm.
it may cause spool issues sometimes because it uses a huge spool to make the before image of that data. And at that time, if any other user want to do any operation, they may not get their own spool space. Well, and one more thing is, if anything happens and it has to restart from the first record onwards if it is a BTQ. But in multiload, it has the restartable capabilities in the log table, so it will start from the last checkpoint onwards.
Okay.
Those are the advantages.
Okay.
Any other questions?
No. Thanks.
Anyone? Okay. So, okay, we should not use a equality condition with the unique primary index. Can you expect why? What happens if I use a equality condition with a unique primary index in the delete query? Well, suppose here, if I have an equality condition on the primary index, how many records I'm going to delete? Can you estimate? With the UPI, if I give an equality condition, how many records I'm going to delete here? Yeah, right. So if it is a UPI, with that UPI value, there will be only one record. So if I use an equality condition with the UPI, effectively how many records we are going to delete? One record. So to delete one record, do I require a multi-delete? If the records which has to be deleted are less, I can use any utility. Maybe SQL Assistant, maybe BTQ. I can use anything, but multiload is not required, so it won't permit at all. If you give a equality condition with the primary index, we are going to delete only one record. Okay, to delete less number of records. When it exactly knows that you are going to delete one record through the multi-delete, it won't permit you. Okay, but inequality condition of UPI is permitted because with inequality condition, you are deleting all the rest of the records not equivalent to the UPI. So you are going to delete multiple rows. So it would allow you. Okay, and an equality with the UPI is permitted. Sorry, NUPI. Okay, but when it is non-unique primary index, then not sure how many rows you will have same as this NUPI. So it would permit you, but it is our responsibility that you have to delete some more data through multi-delete. because it is faster, a block based utility which has restartability capabilities, okay, which occupies the loader slots. Okay, so we have to use multi-delete for deletion of huge data. A DML delete statement is sent to each AMP with match tag parser. Okay, so in the phase, in the application phase, because it won't have acquisition phase, right? Multi-delete don't have acquisition phase because there is no records to be acquired from the host file. So directly it is application phase. So a DML delete statement is sent to each AMP with a match tag parser. So when the table is distributed across all the AMPs would get this instruction of deleting the data in its own AMP, and it starts deleting the data. And it has no acquisition phase because no variable input records to be applied. Yeah, application phase reads each target block and deletes qualifying rows. And all other aspects are similar to the import task. Yeah, all other phases, everything works as similar as the import task, but the only difference is application phase won't exist. Sorry, no acquisition phases won't exist. Apply phase exists to delete the data in each AMP in which it has the matched records, qualified records. Okay. Why use multi-load delete versus SQL delete? The exact question. A multi-load delete is faster and uses less disk space because it won't use transient journals. Okay. And multi-load delete is restartable. Even in case of failure, it will start from the last checkpoint onwards. Okay. What happens if a SQL delete aborted? Teradata applies transient journals. That means huge spool space. If it is a huge data you are going to delete. A SQL delete can be resubmitted but starts from the beginning of the records. Okay, it won't start from the last failure checkpoint because it won't have the capability of log tables and restartability. It has to start from the first record onwards. That's where if it is a huge data, go with the multi-delete. If it is less data, go with SQL deletes. And here I would like to show you a sample script for the multi-applies. Just we'll try to understand what this script does so that you can have an exposure how we can apply multi-conditions, multi-apply conditions. So it is a scenario where we are trying to insert, or we have to maintain the employee dimension. Okay, in order to maintain the employee dimension, what we need to do, there are possible operations. There are three possible operations. That is, if employee exists, it is fine. Okay, if employee exists, it is an year-end process. What we are doing for an employee dimension. Okay, year-end we will give bonus to the employees. Right. So at that time, some employees may be joined newly, and some employees may be going out of the organization. Okay, some people may retain in the organization. So those who retain in the organization, we want to give a bonus. Okay, this is the scenario. So at the year-end process, we are doing three possible operations. One is if an employee is existing, we are giving a bonus to him. If he is a new employee who joined very recently, we want to insert them in the employee dimension. And if the employees are going out, we want to remove those records, those employee records from our employee tables, and we will insert them in the history tables. Okay? We'll remove them from the current tables and insert in the history tables. So these are three possible operations we are going to do. So how we can use multi-load for doing these tasks? The log table, logon statements, and then begin import mload tables. Two tables I am doing it here. Yeah, employee table and employee history. Okay, don't bother about the exact syntaxes here. Just see the concept. Here it is a begin. Import is a default. If it is a delete, you have to mention delete. Begin mload. It is a default. Import is default. Okay, so begin mload tables. Two tables I am maintaining. For each table I have to declare one work table and two error tables. Here it is missed here, but you have to declare those tables. And then the layout of the file from which we are reading the data, the transcode, employee number, department number, and salary. These are the 4 fields exist in the file. And if you observe, the first field is declared as a filler. That means this is the transaction code which gives us an idea what operation we have to do on this employee record. So we are using this field to determine what action to be performed, but we are not going to insert this field in the RDBMS. That's where this field is declared as a filler. Yeah, we'll see where we use this filler in the conditions. Yeah, but we have 4 fields in the file and we have declared the 4 fields, and the first field we are not going to insert into the RDBMS table, but we may use it for calculations or some decision making. So it is declared as a filler. Yeah, and then the DMLs. I'm declaring the DMLs. DML label payroll. Payroll is a user defined keyword, whatever you can write here. And what I'm going to do insert for missing update rows. What is this statement? What this statement indicates? Okay, Ashok has a question. Where do you specify restartability? Okay, in begin Mload statement, we have the checkpoints, error tables, everything to be declared. Okay, if you don't specify, the checkpoint is 15 minutes. The default checkpoint is 15 minutes. If you want to mention, you can mention it. Okay, by default, it is 15 minutes. So the log table is there and checkpoint 15 minutes is there. So after 15 minutes, it will log the data status. Okay, so these many number of records are processed successfully. So that in case of failure, it will see the log table and it will start from the last checkpoint onwards. Yeah, and one more thing is, if you give a checkpoint which is less than 60 number, it takes as the number of minutes. Okay, if you give a number which is more than 60, then it will take the number of records. So after each these many number of records, we have to use a checkpoint. Okay. So this is the DML declaration we are doing. Do insert for missing update rows. That means first it will try to update the record. For any missing updates, it has to insert that row in the table. So what this operation is called? Okay, this operation is upset. Okay, this is the way how we do an upset in multiload. We have to use this keyword to make the upset happen. Okay, do insert for missing update rows, and then write 2 DMLs. One is update and one is insert. Okay, so when you have this keyword, it is expected that we have to write an update statement first and then an insert statement. Okay, so then what it does, whenever you are applying the DML payroll, it will try to update that record to give the bonus. Okay, salary equal to new salary which is coming from the file for this employee. Okay, let's suppose employee number 1 is there already in the table and the employee 1 is already coming from the file. He may get a bonus, so we have to update the salary of the existing employee with the new salary which is coming in the data file. If this employee number is not exist, that is the employee number 1 is not exist in the employee table, that means he's a new employee, so we have to insert his data into the employee table. Insert into employee number and salary. Okay, so first we'll try to update his salary if he already exists. If it won't exist, we will treat him as a new employee joined recently and we'll insert his data into the employee table. And we have one more DML, terminate. It means he is leaving the organization. So what actions we have to do for him? We have to delete him from the employee table. So whatever employee is being terminated, we have to remove him from the employee table and we have to insert his data in the employee history table. Because multiload can operate up to 5 tables, so we are inserting another table, employee history, here in the DML label terminate. Yeah, and finally the action statement. import. Import in file, the data file, and what is the layout to be used? The record layout. Okay. And then what actions to be applied on the records? Apply payroll, that means the DML, upset DML, where the transaction code is pay. Okay, so in the data file, for each record, they will have a transaction code defined. So if the transaction code is defined as a pay, then we will do the payroll DML applied on that particular record. That is upset statement. Okay, whenever the record first field has a value DEL, that means it indicates the deleted employees. So whenever it is a delete, we have to terminate him. So what is the terminate actions? We have to delete the record from employee and insert the data into employee history. That's how we can apply different DMLs based on their actions. Okay, so in transcode, what is this in transcode? It is the input variable from the file and we declare it as a filler. That is, we are using it for some decision making, but we are not inserting into the RDBMS tables. Okay, so we used it for the condition. If the first field of record is pay, then we are going to do a upset based on this DML defined in the payroll. Okay, if the first field of the record is DEL, then we are going to terminate him. So terminate is the DML which is defined with a delete and insert into the history file. And Mload and log off. Okay, so it will go through all 5 phases and it will try to apply the match tag DMLs on each target block only once. Okay, if a record is applied with pay, it is applied with pay only. It cannot be coming into delete again, right? So each record will be applied only once, either into payroll or whether into terminate. Okay, this is how you can use multiple applies based on different actions and different conditions by validating the filler fields. Any questions in this scenario? Okay, we cannot use the upset statement directly. This is the way how we do an upset in multiload. Okay, you cannot do direct upset. Direct upset means it is update else insert statement, right, in the SQL, but it cannot be applied here. Here you have to use the keyword do insert for missing update rows and you have to write 2 DMLs, one update followed by an insert. That is the way we do upset. Any other questions? Okay. And multi-delete we have seen. Checkpoints and restarting multi-loads. So there are different phases and in each phase it has different checkpoint mechanisms. Right? In acquisition phase, checkpointing is performed according to the user and it is based on time or a number of records. A default checkpoint interval is 15 minutes. Right? In the acquisition phase, the default checkpoint is 15 minutes. You can override it by giving a number, and if you give a number within 60 it is taken as number of minutes. If it is more than 60 it is taken as the number of records. And in application phase, checkpoint done after each write of data block. So when the target table is being updated or imported, for each block it will maintain a checkpoint. There is no particular number or time, but each block it will maintain a checkpoint. So whenever it is failed during the application phase, it will restart from the last checkpoint onwards. It is internally maintained. We don't give any number here. Okay, so it is internal, and for each block it will maintain the checkpoint. Okay. Sort operations do their own internal checkpointing. Okay, in the acquisition, when it is sorting the data in the work tables, if something happens, it maintains its own internal checkpoint in the sorting functionalities. Now, how we can restart a multi-load? Okay, release Mload table name. So this is the release statement we have to apply on the target table name when you want to restart from the first record onwards. Okay. If it is acquisition phase, the simple release Mload is enough. But the failure occurs in the application phase, then you have to suffix in apply to the release Mload statement. You release Mload table name in apply, so it releases the lock during the application phase. Okay. So once you release the lock, you have to do the rest of the things. What? Make sure Mload is not running or about this, okay, and enter the release Mload statement, either release Mload table name or in apply based on the phase in which it has failed. Okay, and if release Mload is successful, then drop all the log tables, work tables, and error tables. Okay. If it is not successful, then restart the Mload and let it complete. Or if it is success, then drop all the tables and then handle the errors and resubmit the script, so that it will start from either last checkpoint onwards if it is a restart, or starts from the zero record if it is a rerun. Okay, there is difference in restart and rerun. Restart is executing from the last checkpoint onwards. Rerun means, okay, it runs the entire thing again from the first record onwards. Okay, based on your requirement, you may restart or you may rerun the multi-load script. If it is a restart, just restart, resubmit the script, it will complete automatically. If you want to rerun, you have to do all the tasks. Okay, you stop the script which is being executing currently, release the logs of multi-load, utility logs, and then drop all the error tables, work tables, and log tables, then restart, then rerun. So it will run from 0th record onwards. So actually, there is a limitation on the number of utilities to be used in parallel, because the fast load, multi-load, and fast export, these are called load utilities, which occupies the loader slots. So there is a limitation on number of utilities you can use at a time. You can use maximum of 60 utilities combinedly, the fast load, multi-load, and fast export. Okay, a server can serve up to 60 utilities only, combined fast load, multi-load, and fast exports. And within these 60, it is only 30 for the load utilities, the fast load and multi-loads. Yeah. So combinedly, the fast load and multi-load, we can run only up to 30. And the remaining, after 30, the remaining you can use for fast export slots. Yeah. The fast export limit is 60 minus the number of active fast load and multi-load jobs which are currently running. And this is how we have to calculate how many fast exports still I can execute when these many number of utilities are currently running. Yeah, for example, I have 10 multi-loads running, 10 fast loads running. Then how many fast exports I can still execute? Can anyone calculate? So the calculation is totally it is 60, including fast load, multi-load, and fast export. And within that 60 limit, the loader slot utilities, load utilities are up to 30 only. And fast exports are 60 minus the number of active fast loads and multi-loads which are currently running. Okay, so this is the basic. And what is my problem here? When I have 10 multi-loads and 10 fast loads running, how many fast exports I can initiate? No 10. What is the formula? Yeah, 40. Right? So 60 minus the number of active fast loads and multiloads, that is 10 plus 10. 60 minus 10 plus 10, it is 40. Okay, so let's give me one more problem. I have 5 fast loads running, 10 multiloads running. How many fast exports I can initiate? 45. Again, the same thing. 60 minus the fast loads 5, multiloads 10. So 5 plus 10, 15. Okay, so it is a simple calculation. You have to do the practice. Okay, so one more calculation. I have 10 fast exports running.
Manohar, here we are considering Manohar,
Yeah.
here we are considering whole 60 for utilities, or it is only 30 for utilities?
60 for combinedly the fast load, multiload and fast export. The maximum limit to execute all the utilities combining fast load, multiload and fast export are 60. And within the 60, the sublimit for the loader slots would be 30. Clear? Okay. So anyway, we will start the session tomorrow. I have something to work out. So we'll start from here.
There is any limit for BTEC?
No, no limit for BTQ and T-pumps. Only these three combinedly has the limit. Okay. So anyway, okay, we'll see tomorrow. We will have this regular classes tomorrow by 7 and DBA class by 8 as regular. So we'll meet tomorrow.
Tomorrow we have class?
Yeah. Okay. And then thank you very much. We'll see you tomorrow.